Jupiter is the largest planet around our Sun, and you have been told a simple thing about it since childhood. You were told that Jupiter goes around the Sun. You pictured the Sun sitting still in the middle, patient and fixed, while the planets traced their neat rings around it. But Jupiter has never once orbited a fixed Sun. The point Jupiter actually circles sits about 461,000 miles from the Sun's centre, roughly 29,000 miles above the Sun's own blazing surface, out in empty space where there is nothing at all. That number is worth sitting with for a moment. The Sun's surface lies about 432,450 miles from its core. The balance point that Jupiter loops around floats tens of thousands of miles beyond that edge. It hangs in the vacuum just off the Sun's shoulder, unmarked, cold, and empty. And the Sun does not get to ignore it. The Sun swings around that same point too. If you find that quietly strange, you are exactly where you should be. If you want more nights like this one, a slow walk through the real machinery of the sky, a like or a subscribe helps this channel keep making them, and every episode is on Spotify for when you would rather only listen. That is the whole ask. Now settle back and let the sky get stranger. Here is the machinery underneath your childhood picture. Any two objects held together by gravity do not have one going around the other. They both go around a shared point between them, a balance point, the place where their weight evens out. Physicists call it the barycenter. It is the centre of mass of the pair, the exact spot where the two masses would balance if you could set them on a beam. When one object is vastly heavier than the other, that balance point sits deep inside the heavier one, and the heavier one barely moves. That is why the Sun looks like it sits still. The Sun is enormous. It holds more than 99% of all the mass in the solar system. So for most of the planets, the balance point stays buried somewhere inside the Sun itself, and the Sun's own wobble is too small to notice. But Jupiter is not most planets. Jupiter is a giant. It carries about 1/1000th of the Sun's mass. That sounds tiny, and it is tiny compared to the Sun. Yet 1/1000th of something as heavy as the Sun is still a staggering amount of matter. It is enough. It is enough to drag the balance point of the pair up out of the Sun's core, up through the churning layers, past the surface, and out into open space. So the true picture is not a still Sun with Jupiter circling it. The true picture is two bodies, wildly different in size, both turning around the same empty point in the vacuum. Jupiter travels the wide loop, far out in the cold, one lap every 1186 years. The Sun travels a small, tight loop around the very same point, on the very same 1186-year rhythm. They keep time together. When Jupiter is on one side of that balance point, the Sun leans out to the other side to keep the pair balanced. The whole star nods around a spot with nothing in it. Try to hold that image gently in your mind. The Sun is about 865,000 miles across, a sphere of fire so wide you could line up more than 100 Earths across its face. Its surface is not smooth, it boils, it granulates like the top of a pot of water just before it rolls over, great cells of hot gas rising and cooling and sinking, each one larger than a country. And just off the edge of all that fury, out past the last visible fringe of light, there is a small patch of ordinary empty space. No surface, no glow, nothing to touch. And that quiet patch of nothing is the thing the largest planet in the solar system actually orbits. You cannot see the Sun's answering wobble from here. It is far too small against the vast dark backdrop of the galaxy. The Sun's own path around that balance point is only a few 100,000 miles wide, a slow lazy loop scrawled against the stars. From Earth it would be invisible, and yet that exact motion, a star being tugged in a small circle by an unseen companion, is one of the most useful signals in all of astronomy. Think back to the 6th of October 1995 at the Observatoire de Haute-Provence in southern France. Two astronomers, Michel Mayor and Didier Queloz, pointed an instrument called the Elodie spectrograph at an ordinary-looking star named 51 Pegasi. They watched its light-shift colour in a small repeating rhythm once every 4 days. The star was not doing anything on its own. It was being pulled back and forth around a shared point in space by the gravity of a planet no one could see. That faint rhythmic shift in colour was direct proof, recorded on an instrument, that a star can be dragged off centre by something orbiting it. It was the first planet ever confirmed around a Sun-like star, and it later won Mayer and Queloz the 2019 Nobel Prize in Physics. So the Sun's wobble is not a curiosity, it is a key. The same tug that Jupiter gives our Sun is the tug astronomers now hunt for around thousands of distant stars, listening for that tiny back and forth in the starlight to find worlds they will never directly see. Every wobble is a barycenter at work. Every wobble is a star confessing that it too is not the still centre of anything. Now widen the view a little, because Jupiter is not alone in pulling on the Sun. There are 4 giant planets out there: Jupiter, Saturn, Uranus and Neptune. Each one has its own mass, its own distance, its own steady pull on the star. And the balance point of the whole solar system, the grand average of all that mass, is not fixed. It moves, it drifts, it answers to where the giants happen to be. When those 4 giant planets swing around to the same side of the Sun, their pulls add together in the same direction. They gang up, and the balance point of the entire system gets dragged well out beyond the Sun's surface, out into open space, sometimes more than a full solar radius past the edge. The Sun in that arrangement is looping around a point clearly outside its own body. Then the planets drift apart again, spread out around their separate orbits, and their pulls begin to cancel. One tugs this way, another tugs the other way, and the balance point falls back inward, sometimes settling near the Sun's own core. The centre of the solar system is not a place, it is a running total. It slides in and out across the years as the giants wheel around, breathing outward and inward on a rhythm set by 4 distant worlds. And here is the paradox that will sit over everything you hear tonight. That balance point is not a thing. It has no surface. It gives off no light. It has no gravity of its own, because it is not made of anything. You could fly straight through it and feel nothing, see nothing, register nothing on any instrument. It is a pure average, a bookkeeping point, the mathematical middle of where the mass happens to be. And yet entire worlds bend their paths around it. The Sun itself, 1,000,000 times the mass of the Earth, leans around it obediently year after year. What does it even mean to orbit something that is not a thing? You orbit a place defined only by the stuff around it, a place that shifts the instant any of that stuff moves. The Sun is not falling toward an object. It is falling toward an idea about where its weight belongs, and it keeps missing, and keeps falling, and keeps missing, which is all an orbit ever really is. Nothing here is standing still. The giants wheel around their long, slow tracks. The balance point they define slides out past the Sun's edge and back toward its heart. The Sun answers every shift, nodding and leaning in its own small loop, never quite arriving anywhere, always in motion around a point that itself refuses to hold place. So set the picture in your mind one more time before we go on. The Sun, that huge boiling disk, its surface rolling like the top of a heated pot, every cell of it churning and glowing, and floating just off its shoulder, tens of thousands of miles out in the dark, a small cold patch of empty space with nothing in it at all. Watch the whole star lean and turn around that emptiness, slow and heavy and certain, like a large dancer turning around a partner who is not there. It never stops. It has never stopped. Since before there was an Earth to stand on, the Sun has been quietly circling a point made of nothing, and this is only the first layer. The Sun going around an empty point is the gentlest version of a truth that runs all the way down through everything above you and everything beneath you. Because if the Sun does not sit at a still centre, then the thing you were told orbits the Sun, your own planet, your own ground, the rock under the city where you're lying right now, is not doing the simple thing you were told either. You have always been given a tidy hierarchy, The moon goes around the Earth goes around the sun, each thing tucked neatly inside the next like rings inside rings, every level with a solid centre to hold on to. It is a comforting picture. It is also, in the same quiet way, not quite true. There is a balance point for the Earth and the moon as well, and it does not sit out in open space where at least you could imagine it. It sits somewhere far stranger, somewhere you have been standing on top of your entire life. So keep the feeling of that leaning star with you as we turn toward home. Hold the image of a great mass bending its whole body around a spot that has no surface, no glow, no substance you could ever reach. Because the sun is not the exception here. The sun is the easy, distant, forgivable version of the pattern. The harder version, the one that touches the soles of your feet, is waiting one scale closer in. For a long time, no one thought you could watch this happen. The sun's own loop around the Jupiter point is far too small to see from where you stand. It is a slow lean, buried in the star's glare, invisible from any backyard. But the very trick that hides the wobble around our own star can catch it around a different one, if you know exactly what to look for. That is what happened on the night of October 6th, 1995. The place was the Observatoire de Haute-Provence, in the hills of southern France. Two astronomers, Michel Mayor and Didier Queloz, aimed an instrument called the Elodie spectrograph at a single, ordinary star. The star was 51 Pegasi. Nothing about it stood out. It was a quiet, sun-like star, close to our own in colour and in size, sitting in the constellation Pegasus. Through a small telescope, it would look like any other faint point of light. Unremarkable. The kind of star you would pass over 1,000 times. But the light coming off it was doing something strange. To understand what they saw, you have to understand what starlight carries. When you split a star's light into a spectrum, you do not get a smooth band of colour. You get a spectrum crossed by thin, dark lines, like scratches ruled across the colours. Those lines sit at fixed, known positions. They are a fingerprint printed into the light by the elements in the star itself. And here is the useful part. When a star moves toward you, all of those lines shift a hair toward the blue end. When it moves away, they slide a hair toward the red. The star is not changing colour to your eye. The shift is far too small for that. But an instrument built to measure the exact position of those lines can read the motion straight off the light. That is the Doppler effect, written in starlight. It is the same reason a passing siren drops in pitch as it goes by. Sound waves bunt up as the source comes near and stretch out as it leaves. Light does the same. Mayor and Queloz had built Elodie to catch that stretch and squeeze with almost absurd precision, down to speeds of a few feet per second, the pace of a walk. And 51 Pegasi would not hold still. Its lines crept toward the blue, then eased back toward the red, then blue again, in a clean repeating rhythm. The whole star was drifting toward the Earth, then away, then toward, over and over, not once, not by accident, on a schedule. The cycle came around again roughly every 4 days. Picture the printout. Picture the green pen trace of that Doppler reading twitching in a slow 4-day rhythm on a 1995 lab page in Provence. A small wave rising and falling and rising again, ruled out in ink. That faint wave was the whole discovery. It was the first physical evidence recorded on an instrument of a sun-like star being tugged off its centre by something you could not see. Because a star on its own does not do this. A star sitting alone in space has no reason to swing toward you and then away every 4 days. Something had to be pulling it. Something had to be gripping that star by gravity and hauling it around a shared point in a tight, fast circle. And whatever it was, it gave off no light of its own, or so little that Elodie saw only the star and never the thing beside it. You already know this shape. This is the same off-centre dance you have just been picturing around our own sun. It is Jupiter and the sun, swinging around a point that belongs to neither of them, only smaller and slower in our case, and here caught in the act around a star 50 light-years off. A planet and its star do not take turns. They both circle a common balance point. The heavy one traces a small loop, the light one traces a wide one, and when you sit far away and watch only the star, all you catch is that small loop, the star nodding toward you and away as its unseen partner swings around the far side. So the rhythm told them the partner was there, but the rhythm also told them how strange it was. 4 days, that was the shock. 4 days meant the hidden planet was whipping around its star in an orbit tighter than anything anyone expected. Our own innermost planet, Mercury, takes 88 days to round the Sun. This thing did a full lap in 4. To move that fast, it had to be sitting extremely close to its star, roasting far closer than Mercury sits to us. And to yank a whole sun-like star into a wobble that Elodie could read, it had to be big. Something close to the mass of Jupiter, pressed in tight against the fire. That combination was not supposed to exist. Every model of how planets form said the giants belonged out in the cold, far from their star, the way Jupiter and Saturn sit far from ours. A Jupiter parked right against its star broke the picture. So Meyer and Queloz did what careful people do when the data insults their expectations. They checked it. They watched again on later nights. They ruled out the star simply pulsing or throbbing on its own. They made sure the instrument itself was not inventing the wave. The rhythm held. The 4-day beat came back and back and back exactly on time. What they had found got the name 51 Pegasi b. It was the first planet ever confirmed around a normal sun-like star. Not a hint, not a maybe. A world in orbit around a star much like the one warming your sky, detected purely by the way its gravity made that star lean. And notice how they saw it. They never took its picture. To this day, the planet itself has never appeared as a dot beside its star in these old readings. Everything they knew came from the star's motion alone, from that small swing toward the Earth and away. They read a planet off the wobble of a point of light. They weighed the unseen by watching the seen get tugged around a shared centre in empty space. That is the whole method, and it did not stop with one star. Once astronomers knew the wobble was real and knew how to read it, they turned the same trick loose on the rest of the sky. Point a sensitive spectrograph at a star, watch its lines slide blue and red, time the rhythm. From the size of the swing and the length of the cycle, work backward to the mass of whatever is pulling. Star after star gave up its secret. The wobble hunt became one of the standard ways to find worlds around other suns, and the count of known planets beyond our system climbed from that single case in Provence into the thousands. The recognition came late, but it came. In 2019, Michel Mayor and Didier Queloz shared the Nobel Prize in Physics for that night's work and everything it opened. 2 people, 1 instrument, 1 ordinary star that would not hold still, and a green wave of ink that turned out to be the first proof that the galaxy is full of planets you find not by seeing them, but by catching their stars in a small, faithful off-centre sway. Sit with what that really means for a moment. When Mayor and Queloz watched 51 Pegasi nod toward the Earth and away, they were watching a star obey the exact rule you've been circling all along. No star with a companion truly sits still. It leans, it loops, it trades small circles with the things that orbit it, all of them bound to a balance point that has no surface and gives off no light. The only reason our own sun looks fixed to you is that you live inside its glare and cannot step far enough back to catch it swaying. But it sways. Jupiter alone is enough to walk the whole sun in a slow, patient loop around a point hovering in open space above its own burning surface, and every planet you were ever taught to place in tidy rings around a still centre is really circling that empty balance point instead. So if the sun itself is quietly looping around an empty point in space, the question is no longer whether things orbit the sun, but what your own planet is secretly circling beneath your feet. So if the Sun itself is quietly looping around an empty point in space, the question is no longer whether things orbit the Sun, but what your own planet is secretly circling beneath your feet. The answer is closer than you think. It is about 1,000 miles down. It is a point you could never dig to and touch, and your whole planet is quietly turning round it, right now, tonight. Start with the two bodies, Earth and the Moon. We say the Moon orbits the Earth, and we say it so easily that it sounds like the end of the story. It is not. The two of them are locked together by gravity, and gravity does not care which one we call the important one. It only cares about mass. So before we go anywhere, hold one number in your mind. Earth outweighs the Moon by about 81 to 1. 81 to 1 sounds decisive. It sounds like Earth wins and the Moon simply circles it, meek and small. But 81 to 1 is not infinity to 1. The Moon is not weightless. It has a real pull, and it tugs on the Earth just as surely as the Earth tugs on it. Two masses joined by gravity never let one of them sit perfectly still. They both move. They both circle a shared point between them, a balance point called the barycenter. Here is where the story bends. With Jupiter and the Sun, that balance point floats out in open space, just above the Sun's surface. You might expect the same for Earth and the Moon. A point hanging in the air somewhere between here and there. But Earth is so much heavier than the Moon that the balance point gets dragged in close, not into open space, not up near the surface. It gets pulled down inside the planet itself. Let me give you the exact place. The Earth-Moon barycenter sits about 2,900 miles from Earth's centre. That is roughly 73% of the way in toward the core. Measured from where you stand, it is about 1,000 miles straight down, not in the crust, not in the thin skin of rock we live on. It is buried deep in the mantle in dense, dark, pressurized rock in a place no drill has ever come near. Take a moment with that, a quick beat before we go deeper. If you are enjoying this slow walk through the sky, a like or a subscribe helps more people find these long nights, and the whole thing is on Spotify too if you drift better with your eyes closed. That is the only time I will ask. Now settle back in, because the ground is about to move. There is no cavity down there. There is no hollow chamber, no glowing marker, no little sphere waiting to be found. The barycenter is not an object at all. It is a pure average of where the mass is. It has no surface. It has no gravity of its own. It is a mathematical point sitting inside solid rock, and yet the entire planet organizes its motion around it, faithfully, month after month. So picture what is actually happening beneath a whole city. The dark, pressurized rock of the mantle is tracing a slow monthly circle around a point with no cavity and no marker. The rock does not crack to do this. It does not grind or shift. The whole planet swings together as one body, the way a hammer swings around the hand that holds it. The point stays buried, the rock moves around it, and nothing about it can be felt. Both bodies keep the same clock. Earth and the Moon each complete one loop around that buried point every 27.32 days. That is the sidereal month, the Moon's true orbital period against the stars. The Moon rides its wide, far loop out there in the dark. Earth rides a much tighter one down here. Same rhythm, same 27 days. Two dancers holding the same beat, one stepping wide, one barely stepping at all. Because the balance point is inside the Earth, Earth's own centre never sits still. It traces a small circle of its own, month after month, about 2,900 miles in radius. That is a genuine orbit. It is smaller than the Moon's by far, tighter, quieter, easy to overlook. But it is real. The centre of your planet is not a fixed anchor. It is a moving point on a monthly loop, circling a spot buried in the mantle beneath it. This is why the schoolbook line needs a gentle correction. The Moon orbits the Earth. You have heard it since you were a child. It is not wrong exactly. It is a convenience. It is an approximation we use because it is close enough and easy to say. The fuller truth is that Earth and the Moon co-orbit a shared point together, and that point simply happens to lie underground. Neither one circles the other, both circle the balance between them. The difference is not just words. It changes what you are actually doing as you lie there. You're not resting on a still planet with a small companion wheeling overhead. You're resting on a planet that is itself in orbit. Not around the Moon, not perfectly around the Sun either, around an empty point buried inside its own mantle, about 1,000 miles below the soles of your feet. Think of the ground beneath a whole city sliding through space like a slow turntable you can never feel move. The buildings do not lean, the streets do not tilt. Water sits level in a glass. Every instinct tells you the ground is fixed, and every instinct is wrong. The ground is on a loop. It has always been on a loop. You just live too far from the center and move too smoothly to ever notice the turning. Now let us follow the Moon itself, and here the picture turns stranger still. We draw the Moon's orbit as a tidy circle around the Earth. Little arrows, a clean ring, the Earth in the middle. It makes a good diagram. But that diagram quietly assumes the Earth is standing still, and the Earth is not standing still. It is racing around the Sun at about 66,000 miles an hour, carrying the Moon along with it the whole way. So subtract the Earth's motion for a moment. Ask what shape the Moon actually carves through space, not relative to us, but relative to the Sun. You might expect a spring, a coil, a series of loops as the Moon winds around a moving Earth. That is the natural guess. It is also wrong. The Moon never loops backward. Its path through space seen against the Sun is not a circle around the Earth at all. It is a gentle, wavy line. It always curves the same way toward the Sun at every single point along its journey. The Moon never turns away from the Sun. It never doubles back. It weaves, just slightly, ahead of the Earth and then behind it, a soft ripple riding along a much larger curve. But that ripple always bends inward, toward the Sun's pull, never out. The reason is quiet and complete. The Sun's grip on the Moon is far stronger than the Earth's grip on the Moon, much stronger. So the Moon is not really orbiting the Earth as it crosses the sky. It is falling around the Sun, the same as the Earth is falling around the Sun, and the two of them simply lean toward each other as they fall, trading the lead, weaving a braid so loose it looks like a single soft wave. They are companions on the same long fall. Sit with what that undoes. The Moon does not circle you. Not really. The Moon and the Earth are two bodies falling around the Sun side by side, tugging gently on one another, tracing wavy lines that never once turn their backs on the Sun. The clean ring on the diagram was a convenience too, like the schoolbook line drawn from the point of view of a planet we pretended was standing still. And even the buried balance point will not hold still forever. The Moon is drifting away from the Earth, about 1.5 inches farther out each year, measured with lasers bounced off mirrors the Apollo astronauts left on the surface. As the Moon retreats, its pull shifts, and the barycenter creeps outward too, a little closer to the surface with every passing age. Even the fixed point is not fixed. Even the buried anchor is slowly on the move. So here is the motif I want you to carry with you into the rest of the night. You are already orbiting something you will never see. Not once, not twice. You orbit a point buried in the mantle 1,000 miles down, and you orbit it every month without ever feeling a thing. There is no marker to visit. There is no chamber to enter. There is only the average of the mass sitting in the dark rock with your whole planet wheeling patiently around it. It is a strange kind of comfort, if you let it be. Nothing has to hold still for the orbit to be real. The rock does not need a pivot to turn around. It does not need a thing at the center, only a place, only a balance. The Earth found that balance long before you were born. It has kept it through every night of your life. It keeps it now, silently, while you lie here and the mantle turns. Notice how the ground has quietly stopped being solid ground. It was never the fixed stage you assumed. It is a moving floor on a slow, monthly loop, circling an empty point you could never dig to and touch, carried in turn along a wavy line that always bends toward the sun. Layer by layer, the still world you were promised keeps turning out to be a world in motion, orbiting things that are not even there. And once you accept that the ground is orbiting a buried point, it becomes almost gentle to ask what the sun and all its planets are falling around together. And once you accept that the ground is orbiting a buried point, it becomes almost gentle to ask what the sun and all its planets are falling around together. Because they are falling around something. All of them. The sun, the earth, the moon, Jupiter, the cold grey rocks past Neptune. Every one of them is being carried in the same direction at once, and the thing they are carried around sits so far away that you cannot point to it. It sits at the centre of the Milky Way, tens of thousands of light years from your window. Start with the speed, because the speed is the part that should stop you cold. The sun is moving around the centre of the galaxy at about 514,000 miles an hour. Not the planets around the sun itself. The whole star, dragging everything you know with it, running at 500,000 miles an hour through the dark. You feel none of it. You never will. But before you let this drift past you, do one small thing for the channel. If a calm voice reading you the real size of things helps you sleep, subscribe or leave a like. We are on Spotify too, that is all. Now settle back and let the numbers do the rest. Hold that speed in your hand for a moment. 514,000 miles an hour. At that pace you would cross the entire United States in under 20 seconds. You would go from the Earth to the Moon in less than half an hour. And the sun does not slow down, does not stop, does not turn back. It simply keeps going, the same direction, for your whole life and every life before yours. Now the distance. The sun sits somewhere between 24,000 and 28,000 light years from the centre of the galaxy. The exact number is hard to pin down, because measuring the middle of your own galaxy from inside it is like measuring the middle of a forest while standing among the trees. But roughly 26,000 light years out, the sun holds its lane. It does not fall inward, it does not fly away, it circles. One trip around that circle is called a galactic year, and a galactic year is long. It takes the sun about 230 million years to complete a single lap. Not 230, 230 million. One loop. That is the true length of the sun's year, the real one, the one measured against the heart of the galaxy, instead of against the seasons on your skin. Sit with how strange that makes our ordinary year feel. You count your life in trips around the sun. Birthdays, anniversaries, the slow turn of winter into summer. But the sun counts its own life in trips around Sagittarius A, and each of those trips swallows 230 million of yours. Your entire calendar is a rounding error inside a single galactic season. Here is the part that reaches into deep time. The solar system formed about 4.5 billion years ago. Divide that by 230 million, and you get a number that is almost embarrassingly small. Since the sun and its planets first came together, the sun has completed only around 18 to 20 laps of the galaxy. Call it roughly 20. That is an approximation, not a head count, because the exact distance and the exact speed both carry some uncertainty. But the scale is right. 20 times. In its whole existence, the sun has gone around the galaxy about 20 times. 20. You could count the sun's entire life on your fingers and toes. And now think about what one of those laps really contains. Go back exactly one galactic year to the last time the sun sat in roughly this position on its long circle. 230 million years ago. On Earth, the continents were fused into one enormous landmass, and the very first dinosaurs were only just beginning to appear, small and uncertain, in the world we now call the Triassic. The last time the sun was here on this part of its track, dinosaurs were the new thing. They had not yet grown large. They had not yet ruled. They rose, they spread across 150 million years, and they vanished, all of it inside less than one lap of the galaxy. The sun has not finished the loop it started when those first dinosaurs walked. It is still on it. It is still coming around. So picture the thing at the centre, the anchor for all of this falling. At the heart of the Milky Way sits Sagittarius A, a supermassive black hole with a mass of about 4.1 million suns, 4 million times the weight of our own star, packed into a region you could hide behind the orbit of Mercury. We did not guess at that number. Astronomers tracked a single star near the centre, catalogued S2, for more than a decade, and watched it trace a clean ellipse around a patch of pure blackness. One focus of that ellipse landed exactly on Sagittarius A. From the shape of the path and the speed of the star, the mass fell out of the math. That work earned a Nobel Prize in Physics in 2020. The stars closest to that black hole do not drift, they race. Near the galactic centre, some stars whip around at speeds up to 3.1 million miles an hour. That is 6 times faster than the sun's own pace out here in the quiet suburbs of the galaxy. The closer you fall toward the centre, the harder and faster the falling becomes. Out where we live, 26,000 light-years from the middle, the motion is slow and smooth. We are on the calm rim of a very violent wheel, and nothing here is standing still. Now let go of the diagram you were taught as a child. Forget the tidy poster with the sun fixed in the middle and the planets circling it like beads on wires. That picture is a lie of stillness. The truth is motion, all of it in one direction at once. Picture the sun as it really is. A fireball about 865,000 miles across, its surface boiling and granulating like a pot of light. And that fireball is not hanging in a still, dark room. It is hurtling silently down a pitch-black corridor at 500,000 miles an hour, and it is not travelling alone. It tows 8 planets and a swarm of icy debris behind it, like a comet's tail made of worlds. Earth is in that tail. The moon is in that tail. Every comet, every asteroid, every grain of frozen dust out past Neptune is swept along in the same direction, pulled through the vacuum by the star at the head of the procession. There is no sound to any of it. That is the strange, calming part. All this speed, all this mass, all these worlds, and the whole thing moves in perfect silence. No wind, because there is nothing to make wind. No roar of engines, because there are no engines. Just the sun and its trailing crowd of worlds, sliding through the dark at a pace your mind cannot hold. Quietly, endlessly, the way a leaf might drift down a river if the river were 200,000 light-years wide. Try one more image before you let it all soften. Imagine you could speed the whole thing up. Take 230 million years, one full lap of the galaxy, and compress it into a single second. In that 1 second, the entire solar system would sweep out one smooth, silent circle around the black hole at the centre of the Milky Way. One clean loop drawn in a single heartbeat. And now think about what fits inside that one arc. Every ice age Earth has ever known would happen somewhere along that single circle. Every warm age between them, the rise of the mammals, the first upright walk of your earliest ancestors, the whole span of human history, every empire, every language, every person who has ever lived and everyone alive right now, all of it would occur within one small stretch of that quiet 250,000,000-year curve. You could not even mark where. Your entire species would not fill a visible sliver of a single lap. That is what the sun is doing while you sleep tonight. It is not sitting at the centre of anything. It is carrying you along the edge of a slow, enormous circle, one it has traced maybe 20 times, one it will keep tracing long after everything you recognise is gone. And it does this smoothly. That is the last thing to hold on to before we go further. The sun's galactic orbit looks calm. It looks like a wheel that has always turned and always will. From inside a single human life, or 1,000 human lives, or the whole run of recorded history, the motion never wavers. The sun holds its lane. The planets stay in their tail. The great circle keeps its shape. Everything about it says permanent steadiness, a clockwork too vast to break. Raw narration only follows. No local file writing tool is available in this session, so the insert is delivered in line. Splice it in ahead of the anchor sentence. Turn your attention now to a single star. Astronomers gave it a plain name. They call it S2. In an older catalogue it wears a second label, S02. It is not a famous star. You will never see it with your own eyes. It sits deep in the crowded heart of the Milky Way, buried behind curtains of gas and dust 26,000 light-years away. And yet for more than a decade, patient telescopes on the ground did nothing but watch it. Night after night they measured exactly where it stood. Slowly, dot by careful dot, a shape emerged from all those measurements. It was an ellipse. A single star scribing a clean, silent ellipse around a patch of total blackness at the galaxy's core. Not a rough loop, not a smudge, a precise closed curve, the kind of oval you could draw with a pencil, a pin, and a loop of string. S2 was tracing that oval around something, and when the astronomers looked at the empty place the star was circling, they found nothing there. No bright object, no visible mass, just dark, quiet space at the exact centre of the loop. Here is the part worth holding on to as you settle in. That empty place is not empty at all. It has a name. Sagittarius A star. It is the supermassive black hole at the centre of our galaxy, and the only reason we can weigh it is that one small star kept faithfully falling around it. Think about what an ellipse actually tells you. Centuries ago, Johannes Kepler worked out the rules of orbits. He found that a planet does not trace a perfect circle. It traces an ellipse, an oval with two special interior points called foci, and the object being orbited does not sit in the middle of that oval. It sits at one of the two foci, off to the side. That single fact is a weighing scale. When astronomers plotted the full shape of S2's orbit, they could find its two foci, and exactly on one of them sat Sagittarius A star. The star was falling around that focus again and again, obeying the same law Kepler wrote down for the planets around the Sun. Once you know the shape of an orbit, you can read its speed, and once you know both the size and the speed, Kepler and Newton hand you the mass of the thing at the focus. There is no way around the arithmetic. A fast, tight orbit means an enormous unseen mass pinning the star in place. A slow, loose orbit means something light. S2 does not move slowly. As it swings closest to that dark focus, it whips around at a staggering pace. At its nearest approach, it reaches speeds of millions of miles per hour, and the stars nearest the very centre can move faster still, up to about 3.1 million miles per hour. Nothing ordinary could hold a star moving that fast on such a tight leash. Only a monster could. When the numbers were finally solved, the mass came out staggering and precise at the same time. About 4.1 million times the mass of the Sun. 4 million suns, packed into a region smaller than the orbit of the innermost planet. Dark, silent, utterly invisible, and yet its presence was written, plain as handwriting, in the path of one faithful star. Let that sink in for a moment. No one ever saw the black hole, not directly, not in this measurement. There was no picture of it, no glow, no edge to point at. There was only a star and its ellipse. The blackness in the middle was inferred entirely from how a single point of light chose to move. The orbit was the evidence. The orbit was the whole proof. That is the quiet power of gravity. It cannot hide. An object can give off no light at all, swallow every ray that falls into it, and still it cannot conceal its mass, because mass bends the paths of everything nearby, and a bent path, tracked carefully enough, will always point back to the thing doing the bending. This is exactly the same logic you have been following all along, only turned up to an unimaginable scale. When you look for the balance point between two ordinary worlds, you watch how they move and let the motion reveal the hidden centre. You never have to see the balance point itself. You only have to see the path curving around it, and the curve tells you where the centre must be and how heavy. Here it is again, at the heart of a galaxy. A star bends its path around a place you cannot see. You measure the bend. The bend tells you the mass. The same reasoning that finds a barycenter buried in empty space finds a black hole hiding in plain sight. It is one idea stretched from the space beside a planet all the way to the core of the Milky Way. The work behind this was slow and unglamorous. It took two rival teams of astronomers more than 20 years of observations, one led from Germany, one from California, pointing the largest telescopes on Earth at the same tiny patch of sky, year after year. They had to peer through the shimmer of our own atmosphere and the haze of galactic dust. They corrected, and corrected again, and waited for the star to move. And it did move. Over the years, S2 completed enough of its long orbit to draw the full ellipse. Its orbit takes roughly 16 years to close, so a single lap is most of a human career spent watching. When the loop finally closed and the shape held true to Kepler's law, the case was sealed. The dark thing at the focus was real, and it was enormous. In 2020, that patient work was honoured with the Nobel Prize in Physics. It went to Reinhard Genzel and Andrea Ghez, the leaders of those two teams, for showing that a supermassive compact object governs the orbits of stars at the centre of our galaxy. A prize, in the end, for reading a black hole out of the motion of a star. For proving, from geometry alone, that 4 million suns of darkness sit at the middle of everything we call home. There is something worth carrying with you in that. We tend to think seeing is believing. But the deepest thing at the centre of the galaxy was never seen in that measurement. It was deduced from a curve, from the humble fact that things in orbit trace ellipses, and the mass they orbit hides at a focus, waiting to be weighed by anyone patient enough to watch. So picture it once more before we widen the view. One small blue star, far too faint for your eyes, sweeping through a long silent oval around a knot of pure blackness, 4 million times heavier than the Sun. It has done this for longer than there have been astronomers to notice, and it will keep doing it long after. It does not orbit the middle of its own loop. It leans around a dark point off to one side, exactly as Kepler said it must. And now lift your gaze from that one star to the neighbourhood around it. Every star you can see on a clear night belongs to this same galaxy, and this same centre governs them all. The Sun is one of them. Our own star, with all its planets in tow, is also falling around Sagittarius A star, only from very far out, on a loop so vast it dwarfs anything S2 has ever traced. You're riding on that loop right now, carried around the same black hole, held by the same gravity, tracing the same kind of curve. We measure that motion the way we measured everything else. We watch the path bend, and we trust the bend. From out here, so far from the core, the Sun's great orbit looks perfectly smooth, perfectly reliable, a circle you could set a clock by. It seems as fixed and eternal as anything in the sky. Yet a lap that takes 230 million years only looks steady because no one has ever watched it long enough to see it come apart. Yet a lap that takes 230 million years only looks steady because no one has ever watched it long enough to see it come apart. Watch anything closely enough and the smoothness dissolves. The planets are no exception. You were taught that they trace fixed ellipses, the same loop again and again, reliable as a clock. That picture is true for a while. It is not true forever. The 8 planets do not move in perfect, eternal grooves. Their orbits are chaotic. That word has a precise meaning here. It does not mean random and it does not mean violent. It means that tiny differences grow. A small uncertainty in a planet's position today becomes a large uncertainty later. The error does not stay small. It doubles, then doubles again. Astronomers put a number on this. It is called the Lyapunov time. For the solar system, it is about 5 million years. Hold that figure for a moment. 5 million years is the horizon of prediction. Inside it, the math behaves. Beyond it, precision fails. Here is what that really means. Suppose you knew every planet's position today to the nearest inch. Every speed, every angle, measured perfectly. You feed it all into the finest simulation ever built. Run it forward 5 million years and it still tracks. Run it forward 10 million years and your answer is worthless. Not slightly off, worthless. The errors do not add up gently, they compound. Picture a hairline crack spreading silently through a sheet of ice. It starts as a line you can barely see. Then it branches again. Each split feeds the next. The tiny becomes the total. That is chaos, and the planets are living inside it right now. Before we go further, one small thing. If you find these ideas quietly loosening something in your chest, a like or a subscribe helps this channel reach other people who like to fall asleep to the shape of the universe. You can also find us on Spotify. That is the whole ask. Now let the sky keep opening. So why are the orbits chaotic at all? Why can't the equation simply be solved the way they solve two bodies circling each other? The answer is old and it has a name. It is called the N-body problem. Two bodies are easy. A star and a single planet alone in the dark trace clean, closed curves around their shared centre. You can write their motion down in a neat formula. Give it any moment in time and it hands you their exact positions. No approximation, no drift. The two-body problem is solved, completely, forever. Add a third body and the neatness collapses. Now each object pulls on both of the others. Each pull changes a path. Each changed path changes the next pull. The three tugs feed back into one another with no clean end. There is no general formula that hands you the future. You can only step forward carefully, moment by moment, and watch. Now imagine not 3 bodies but 8 major planets, plus dozens of moons, plus a swarm of asteroids and comets, all pulling at once. The tugs stop combining in any simple way. This is the heart of it. With 4 or more gravitating bodies, the mutual pulls no longer add up into something you can fold into a single tidy equation. The system has no general closed-form solution. It never has. This is not a gap in our cleverness that some future genius will close. It is a feature of the mathematics itself. Even the greatest minds ran straight into it and could not pass. Consider Isaac Newton. In the 1680s, in the Principia, he laid down the laws that still govern every rocket and every moon. He gave the world gravity as an equation, and then he tried to use it on the simplest hard case there is. Just 3 bodies, the sun, the earth, and the moon. He could not fully solve it. The man who had unlocked the heavens could only approximate the moon's motion, and his approximation carried an error of about 8%. 8% for the closest neighbour we have. He reportedly said the problem gave him headaches. The sun and the earth kept pulling on the moon at once, and the 2 pulls would not resolve into a clean answer. Sit with that for a moment. The foundational mind of physics, holding the correct law of gravity in his hand, defeated by 3 objects. Not because he lacked the law, but because 3 bodies bound by gravity simply do not yield a formula. If 3 broke Newton, 8 were never going to hold still forever. For a long time this stayed a puzzle about prediction. We knew we could not forecast the far future, but we told ourselves the orbits were probably stable anyway, just unpredictable in their details. Perhaps the planets would wander a little and always settle back. Perhaps the ellipses, while not perfectly fixed, were at least permanent in the ways that mattered. That last comfort has now been taken away. In May of 2023, mathematicians published something new. Not a simulation, which can always be doubted. A rigorous proof. They showed that planetary systems arranged like ours are inherently unstable over long enough timescales. Not merely hard to predict, provably unstable. Given enough time, the configuration is guaranteed to change dramatically. Understand what a proof is against a simulation. A simulation is an experiment on a computer. You run it, you watch, you see what tends to happen. A proof is a certainty. It says this must be so in every case that fits the setup, no matter how long you wait. The 2023 result moved planetary instability from something we suspected into something we know. The way it unfolds is patient, almost gentle. The geometry can hold steady for an immense span of time. Ages pass. The planets trace what look like the same loops, generation after generation, for millions and then hundreds of millions of years. Nothing seems to be happening, and then, without any single dramatic trigger you could point to, the arrangement is simply different. Steady for a very long time, then changed. That is the signature of chaos playing out across deep time. Here is the image to carry with you into sleep. Forget the clean diagram of rings around a dot. Picture instead 8 balls rolling on a great warped rubber sheet. The balls roll, and their weight bends the sheet. But the sheet is not fixed. It is itself slowly reshaping under their combined weight, permanently, with no repeating pattern. The balls change the surface changes the balls, around and around, and the shape never once comes back to exactly where it began. That is your solar system, seen across enough time, not a clock, a landscape that never stops rewriting itself, so slowly that within any human life it looks like stone. Now comes the part that must be said carefully, because it is easy to turn a whisper into a scream. You may have heard that Mercury could one day fall into the Sun, or crash into Venus. It is worth being precise about what the science actually says, because the truth is stranger and quieter than the headline. Some simulations, run forward over billions of years, show a small but real chance that Mercury's orbit becomes unstable. In a fraction of those runs, its path stretches and shifts until, in the far future, it could collide with Venus, or plunge toward the Sun. But hold on to the numbers. This is a low probability, spread across billions of years. It is not a forecast. It is not a date on a calendar. Nobody is predicting that this will happen to Mercury. What they are saying is that it is no longer impossible, and that over enough time even the innermost planet is not perfectly safe. That is the honest shape of it. Not doom, just the removal of a guarantee. The inner planets are not locked in place by any law that says they must stay. They are held by a balance that is stable now, and probably stable for an enormously long time, but not certain across the full stretch of the future. The chance is small, the timescale is vast, and the mere existence of that chance is enough to change how you see the sky. Because think about what it undoes. The oldest comfort we take from the heavens is their constancy. The stars were here before us and will be here after. The planets wheel in their courses, faithful, unchanging, the one thing you can count on. That is the feeling children get from a model of the solar system, all those little spheres on their wires turning forever. The wires are not real, there are no grooves, there is only gravity, pulling every body on every other body at every instant, in a great knot that no equation can untie. The stillness you see when you look up is real, but it is a local stillness. It belongs to your time scale, not to the universe's. 5 million years is the edge of what can be known. 8% was the best Newton could do with 3 bodies, and a rigorous proof now says the whole arrangement must eventually come apart. None of this is frightening in the moment. You will not feel it. Not tonight, not in 10,000 lifetimes. The Earth will hold its orbit. The seasons will keep their turn. The changes we are speaking of are written in a script so slow that the entire history of life fits inside a single steady-looking chapter. But the chapter ends. That is the whole quiet weight of it. The planets are not exempt from time. They only appear exempt because our watching is so brief. Return one last time to the rubber sheet. 8 balls, rolling, the surface bending beneath them and reshaping and never repeating. There is no final frame where it all locks into place. There never was. The order you were promised was a snapshot mistaken for a law. Look long enough, and the crack in the ice keeps spreading. Silent, patient, sure. You can rest inside this. There is nothing here to fear. The instability lives in a future so distant that it may as well be another universe, and you are only being asked to notice that the ski is not the fixed thing you were told it was. It is a slow motion, a drift with no destination, a balance held for now. I don't have file tools in this session, and this insert task calls for raw narration output only. So here is the finished insert D, approximately 600 words, written to flow into your anchor sentence. Not everything ahead is settled. Some of it sits in an honest middle, where careful people still disagree. It is worth walking through slowly. The disagreements say almost as much as the facts. Start again with the sun's larger path. You already know it carries the whole solar system around the Milky Way. That loop is not perfectly flat. As the sun travels, it also rises and sinks through the crowded plane of the galactic disk. It climbs a little above the midplane. It slows. It settles back down through the crowd of stars and drifts to the other side. One full rise and fall takes somewhere near 30 to 40 million years. Picture a horse on a carousel, easing up and down while the whole ride turns. That gentle bobbing is real. What comes next is not. Some researchers looked at the fossil record and thought they saw a faint rhythm in it. Great die-offs spaced out across deep time, almost like a slow pulse. They noticed the numbers were not far off. The sun's up and down cycle runs in tens of millions of years. Some readings of the extinction record seem to run on a similar clock, so they asked the obvious question, could the two be linked? The idea has a certain pull. Perhaps each path through the dense midplane jostles distant comets loose. Perhaps it nudges a few of them inward toward the inner worlds. Perhaps it changes how much radiation reaches us. Any of those could, in principle, leave a mark in the rocks. But you should hold this one lightly. The fossil timing is loose, not sharp. The extinction record is noisy and easy to read too generously. No one has shown a clean mechanism carrying the sun's motion down into the biology of Earth. This is a proposed connection, not a proven one. Most astronomers file it under interesting unconfirmed. So do we. It is a question with a shape, not an answer with a foundation. Now come back inward, to a debate you have met once already, Mercury. You may have heard that Mercury could one day be lost, that its orbit could stretch, cross paths with Venus, or fall into the sun. It is easy to hear that and picture a countdown. There is no countdown. This is a debate about probabilities, not a forecast of an event. Here is what the work actually shows. When mathematicians and astronomers run the solar system forward, they cannot do it just once. The orbits are chaotic. Tiny uncertainties today grow into total uncertainty after about 5 million years. So instead they run the system again and again, thousands of times, each with slightly different starting conditions. What they get back is not a single fate. It is a spread of possible futures. In the overwhelming majority of those futures, the planets keep their familiar arrangement for as long as the sun will live. In a small fraction, something drifts, and when something drifts, it is almost always Mercury. It is the smallest planet, the innermost, and the one on the most stretched orbit. In that thin slice of runs, its path lengthens over billions of years, until in rare cases it crosses Venus or plunges toward the sun. Notice the words that matter. A small fraction. Over billions of years. Rare cases. This is not a prediction that Mercury will be destroyed. It is a statement that the equations do not forbid it, given almost unimaginable amounts of time. In 2023, mathematicians proved that a system like ours must eventually change. They did not and could not say exactly how or exactly when. Mercury is simply the loose thread the models tug on first. It is a low chance over an enormous span, and nothing about tonight or this age of the world hangs on it. So the inner solar system offers you a maybe. Now look outward, past the galaxy entirely, to the largest maybe of all. Our whole galaxy is falling, not around anything you can point to. The Milky Way, together with Andromeda and dozens of smaller galaxies, is streaming through space at more than 1 million miles an hour. Roughly 1.3 million miles per hour, all in one direction, toward a place astronomers name the Great Attractor. And here is the strange part. They still cannot see what is there. The Great Attractor is not a single object. It is a low point in the landscape of gravity, the densest region of the vast supercluster we belong to. Everything in our neighbourhood is sliding toward that basin the way water finds the bottom of a bowl. We can measure the fall precisely. We can chart the motion of galaxy after galaxy, all leaning the same way. What we cannot do is look straight at the source. The problem is our own home. The Great Attractor sits almost directly behind the thick central plane of the Milky Way. That plane is packed with stars, gas, and above all dust. The dust does not glow, it blocks. It smears out the visible light of whatever lies behind it. Astronomers gave that blocked band an honest name. They call it the zone of avoidance. It is like a dust-smeared windshield you must infer through rather than see through. You cannot make out the road ahead directly, but you can watch how everything else on the road behaves. You can see the cars around you all drifting toward the same unseen dip, and from their motion you can work out that the dip is there and roughly how deep it must be. That is what our astronomers do with the Great Attractor. They read its pull in the paths of galaxies they can see and infer the mass they cannot. Some of that hidden weight has been mapped in other kinds of light that pass through dust more easily. Enough to know this pull belongs to something even larger. In 2014, the astronomer Brent Tully and his colleagues traced the full sweep of these flows and gave our home's supercluster a name, Laniakea. It stretches roughly 500 million light-years across. It holds around 100,000 galaxies, and all of them, ours included, are drifting toward the same shared low point, like rain finding one slow valley. But what physically sits at the heart of it stays uncertain. Its densest core hides in the zone of avoidance, behind the glare and dust of our own disk. We know the pull. We do not have a clean picture of the puller. That too is a genuine open question, not a solved one. And this is where the largest question of all quietly opens beneath the others. You might expect that all this falling has to lead somewhere, that if galaxy flows towards supercluster, and supercluster leans towards some deeper basin, then far enough out there must be a true middle. One place the whole universe is arranged around, a centre to hold on to. Current cosmology says there is no such place. The expansion of the universe has no centre point anywhere. There is no spot you could travel to and stand at the heart of it all. Every galaxy sees the others drifting away, and every galaxy could just as fairly call itself the still one while the rest recede. There is no edge. There is no middle. There is only relative motion. Everything moving with respect to everything else, and no privileged place from which all of it is measured. That is not a gap waiting to be filled by a better telescope. It is the current understanding of how the universe is built. Not a hall with a centre and walls, but something without a middle at all, expanding everywhere at once. So keep the honesty of these three open threads. The sun's slow bobbing through the disk is real, but the link to extinctions is only proposed and unproven. Mercury's possible unravelling is real in the equations, but only as a faint chance across billions of years, never a scheduled event. The Great Attractor's pull is measured to fine precision, but its heart stays hidden behind our own dust, inferred rather than seen. In each case you're handed a clear fact and an unfinished picture in the same breath, and notice what all three quietly refuse to give you. A fixed point, a place to stand, a centre that stays put while everything else moves around it. The bobbing has no floor, the planets have no guaranteed arrangement, the Great Fall has no visible bottom, and the universe as a whole has no middle to fall toward. If even the planet's neat ellipses are only borrowing their stillness from short human timescales, then the last comfort left to remove is the idea that anything, anywhere, holds a fixed centre. If even the planet's neat ellipses are only borrowing their stillness from short human timescales, then the last comfort left to remove is the idea that anything, anywhere, holds a fixed centre. If even the planet's neat ellipses are only borrowing their stillness from short human timescales, then the last comfort left to remove is the idea that anything, anywhere, holds a fixed centre. You have followed the falling this far. You watched the sun lean around a point above its own surface. You felt the ground trace a monthly circle around a spot buried in the mantle. Now let the frame open all the way. Start with what an orbit really is. Isaac Newton pictured gravity as a pull, a rope of force reaching across empty space. That picture works beautifully for most things. But Einstein gave a stranger and truer one. Under general relativity, gravity is not a pull at all. A massive object bends the shape of space and time around it. The bending is the geometry of the universe itself. An orbiting body is not being tugged, it is falling. It follows the straightest possible line through curved space, a path physicists call a geodesic. The moon is in freefall, the Earth is in freefall, every planet is falling forever along the smoothest track the geometry allows. Hold that word gently. Falling. Not a barycenter to circle, though that math still works. Something deeper. Every orbiting thing is in continuous freefall, and it never lands because the ground itself keeps curving away. There is no floor at the bottom of a geodesic. Before we fall the rest of the way, one small thing. If these quiet layers of motion are the kind of thing you want more of at night, a like or a follow helps this reach other sleepless people, and the whole series is on Spotify too. That is all. Now let yourself sink back into the falling. Here is the first surprise about your own speed. You feel perfectly still tonight. You are not. The whole solar system is moving through the ancient light of the universe, and we can measure exactly how fast. That ancient light is the cosmic microwave background. It is the faint afterglow of the young cosmos, released when everything was hot fog, now cooled to a whisper across the sky. If you were truly at rest, that glow would look the same temperature in every direction. It does not. One side of the sky is very slightly warmer. The opposite side is very slightly cooler. Astronomers call this the dipole. It is the signature of our own motion. We are moving toward the warm side, so its light gets crowded and looks hotter. We are moving away from the cool side, so its light stretches and looks colder. From that tiny lopsidedness, the number falls out. The solar system is moving at about 370 kilometers per second relative to that ancient light. In the units your body understands, that is roughly 828,000 miles per hour. You're reading this while riding a star that is racing through the oldest light there is, faster than 800,000 miles every hour. You feel none of it. There is no wind, no sense of speed, because everything near you is moving together. That is the quiet trick of freefall. It hides itself. Now widen the frame again. The sun does not move alone. It carries the whole Milky Way with it, and the Milky Way travels in a crowd. Our galaxy belongs to a small cluster called the Local Group. It holds the Milky Way, the Great Spiral of Andromeda, and dozens of smaller galaxies trailing along. This whole family is not just drifting with the general expansion of the universe. It has its own extra motion on top of that expansion, its own peculiar velocity, and it is large. The Local Group is moving at over 600 kilometers per second relative to the smooth outward flow of cosmic expansion. Something is pulling the entire neighborhood in one direction. Whole galaxies, each holding hundreds of billions of stars, are streaming the same way at once. Follow the Milky Way itself in that stream. Our galaxy, with everything in it, including you, is being drawn toward a single region of space at about 1.3 million miles per hour. That is the pace of the falling at this scale. A galaxy is not a still thing. It is a leaf on a current. The place it is falling toward has a name. Astronomers call it the Great Attractor. And here the story turns strange, because for all our instruments, no one has ever clearly seen what is there. The Great Attractor is not a single object. It is not a giant star or one enormous black hole waiting at the end of the current. It is a gravitational low point, the densest, heaviest region in the vast structure our galaxy belongs to. Imagine the whole neighborhood of galaxies draining toward a hidden basin. like water sliding toward a low point you cannot see. That basin is the Great Attractor. The structure it sits inside was mapped and named only recently. In 2014, the astronomer R. Brent Tully and his collaborators traced the motions of thousands of galaxies and found they all belong to one enormous connected flow. They called it the Laniakea supercluster. The word comes from Hawaiian, meaning immense heaven, and the name is honest. Laniakea spans roughly 500 million light-years across. It holds something like 100,000 galaxies, and all of them, our own included, are flowing inward toward that shared basin of attraction. Tully's team did not draw a cluster so much as a watershed, the region of space whose galaxies all fall the same way. Nothing here is standing still. Every galaxy in that map is sliding down the same slope, toward the same hidden low point, at once. So why can we not simply look at the Great Attractor and see what does the pulling? Because it hides behind our own galaxy. Look up at the band of the Milky Way, and you see a bright river of stars. You also see dark lanes cutting through it, ribbons of dust that block the light behind them. From our seat inside the galaxy, that dust forms a wall. There is a whole strip of the sky where the Milky Way's own disk stands in the way, and we cannot see the distant universe through it clearly. Astronomers call that strip the zone of avoidance. It's a literal blind spot, a region we must infer through rather than see through. And the densest heart of the Great Attractor lies partly behind it. The very thing pulling our galaxy sits in the one direction we can barely observe. So we know it by its effect, not its face. We watch galaxy after galaxy falling the same way and read the current from their motion. We can measure the pull with real numbers while the source stays hidden behind dust. You're being carried towards something no telescope has ever cleanly imaged. Let all of it stack up now, one motion resting on another. You sit on the Earth. The Earth circles the buried barycenter it shares with the Moon. That pair falls around the Sun. The Sun tows the solar system around the galaxy's black hole at 500,000 miles an hour. The galaxy streams with the local group at over 600 kilometers a second, and the whole crowd pours toward a hidden basin at 1.3 million miles an hour. There is no bottom step. Each thing you might have called fixed turns out to be riding on something else that moves. The universe has no chair to sit in, no still platform from which the rest goes by, every surface itself already sliding around something else. This is not a mystic's idea. It is the daily working reality of the people who measure the cosmos most precisely, and it forces a very practical choice on them. When astronomers need a truly steady reference point, something to measure everything else against, they cannot use the Sun. The Sun wobbles. Jupiter and the other giant planets keep nudging it around, so its centre drifts on its own small loops. A star that swings around a moving point is not stable enough to build a coordinate system on, so they use the solar system barycenter instead. Not the Sun's body, but the shared centre of mass of the whole planetary family, the balance point of everything at once. That abstract point sitting sometimes inside the Sun, and sometimes just beyond its surface, is the closest thing to a fixed anchor the solar system offers. It is a mathematical average, and it is steadier than the star. You can see why in the work of pulsar timing. Across the sky, dead stars called pulsars spin and sweep out beams that reach us as clockwork ticks, some of the most regular signals in nature. Teams like Nanograv listen to many of them at once, hunting for the faint stretching of space that a passing gravitational wave would cause. But to hear those ticks cleanly, they must first remove our own motion. The Earth swings around the Sun wobbles around the barycenter itself drifts. Every one of those motions would smear the timing of a distant pulsar, adding false wobble to a signal that should be perfectly steady. So the astronomers subtract them, layer by layer, and refer every measurement to the barycenter instead of to any moving body. Only then does the pulsar's heartbeat come through clean. Sit with what that means. The people searching for ripples in space-time itself begin by admitting there is nothing solid to stand on. They build their anchor out of arithmetic, not out of any object, because no object holds still. Even their fixed point is only the best available approximation of 1. And notice what is missing from this whole picture, all the way out. There is no center to the expansion of the universe. The cosmos is not flying apart from some special spot you'd travel to and find calm. As far as we can tell, expansion has no center at all, only everything moving relative to everything else. The falling has no floor and the spreading has no middle, so the childhood diagram quietly dissolves. The sun in the center, planets on their tidy rings, was never the shape of things. It was a convenience true enough for a single human life, false across deep time and large space. Every ring hangs on a point that moves. Every point rides a current that pours toward a basin you cannot see. Let your body feel how still the night is around you, and then remember the truth underneath that stillness. The bed does not move, but the ground it rests on traces a monthly loop. The loop falls around the sun falls around the galaxy pours toward Laniakia's hidden low point at more than 1,000,000 miles an hour. You are, at this exact moment, in freefall on every scale at once, and it feels like perfect rest. That is the last comfort gone, and it turns out to be no loss. Nothing was ever fixed, and yet here you are, held steady enough to close your eyes. The falling is not a threat. It is simply the shape of things, older and wider than any center you were told to trust. Consider what those astronomers are actually up against. Out in the dark, far beyond our own star, a dead sun is keeping time. It is a pulsar, the crushed remnant of a star that collapsed and died. It spins, fast and tireless, and it throws a narrow beam of radiolite out across space. Each time that beam sweeps over the Earth, a tick arrives. The ticks come with a regularity that is almost unnerving, one after another. Some of these dead stars are steadier than almost anything you have ever held in your hands. That steadiness is the whole point. It is a clock hung in the sky, built by gravity rather than by human hands. If you could stand still and listen, you would hear a pulse so even you could set your whole life by it. But you cannot stand still. Nothing here can. And that is exactly where the trouble begins. You're not listening from a fixed place. You are riding the Earth. The Earth is racing around the Sun at roughly 66,000 miles an hour. Across half a year, the planet swings from one side of its orbit to the other, a gap around 186 million miles wide. Some months you're sweeping toward that distant pulsar. Other months you're sweeping away from it. When you move toward a source of ticks, the ticks bunch up and arrive a little early. When you move away, they stretch out and arrive a little late. So the clock in the sky, perfect as it is, seems to blur. It seems to speed up then slow down in a slow, yearly breathing. The pulsar has not changed at all. You have. The jitter is yours, smuggled into the data by your own steady fall around the sun. Think about how small the true signal is. It hides beneath everything louder. At that level of care, even the slow drift of your own planet becomes a loud, obvious intruder. 66,000 miles an hour is not gentle when you're measuring the arrival of light this closely. Left alone, your own motion would simply drown the thing they came to find. Now think about how the astronomers take it back out. They do it in layers, one correction stacked upon the next, peeling every scrap of movement off the signal until the true heartbeat comes through clean. The first layer is the Earth. They know your orbit with enormous precision. They know where the planet sat and how fast it moved at the exact instant each tick landed in the dish. So they perform a piece of careful arithmetic. They ask what the ticks would have looked like if the receiver had never been circling the sun at all. They lift the whole orbital swing out of the numbers. The yearly bunching and stretching quietly falls away. The size of that correction depends on where the pulsar sits. A star straight ahead of the planet's motion feels the full effect. A star off to the side feels far less. So the astronomers must know not only how fast the Earth moves, but in what direction it moves relative to each pulsar in the sky. Every star in their catalogue gets its own tailored correction, shaped by the angle between it and the planet's path. But that first layer is not nearly enough. Peel off the Earth, and the Sun is still not sitting still. The Sun itself is being tugged in slow loops by its own planets, most of all by Jupiter. So the astronomers strip that away too. They subtract the Sun's own small wobble around the balance point of the entire solar system. Another layer of motion, lifted off and set aside, and even that leaves one more layer underneath. The balance point itself, the barycenter, is drifting. As the giant planets wheel around and change their arrangement, the shared centre of the solar system slides. Sometimes it sits out beyond the Sun's blazing surface. Sometimes it falls back toward the Sun's core, so the astronomers account for that motion as well. Earth's swing, then the Sun's wobble, then the barycenter's drift, one clean subtraction after another, in order. What they are left with is a set of ticks referred to none of moving things, not to your restless planet, not to the Sun, but to the barycenter of the solar system itself. That empty point becomes the still place they were never handed. They have manufactured a radio-quiet hush by peeling every layer of motion off the data, until a neutron star's heartbeat comes through clear. It is a strange kind of silence to build. There is no knob to turn, no shield to raise against the noise. The quiet is made entirely of arithmetic. Every source of motion they know about is written down, modelled, and then subtracted term by term, until what remains is the star and nothing else. The hush is not found. It is constructed, one correction at a time. Here is the part worth sitting with in the dark. They do not choose the Sun as their fixed frame. The Sun is a star, and a star is not steady enough to trust. It leans and loops around the barycenter on its own long schedule. Tie your measurements to the Sun's centre, and you inherit every bit of that wandering. So the chosen anchor is the barycenter instead. It is the mathematical average of where all the mass in the solar system lies. It is a spot with no surface, no light, and nothing at all to see. Remember what this anchor actually is. It is not a landmark. There is no buoy floating there, no stone you could set your hand against. In one arrangement of the planets, it hovers in open vacuum above the Sun. In another, it lies buried inside the Sun itself. It has no gravity of its own and no matter at its heart. It is a number, a weighted average, and yet whole worlds bend their paths around it, and every careful measurement leans on it. This is not some rare, heroic calculation, done once and then framed on a wall. It is routine. It happens every single time the data comes in. There is a collaboration built for precisely this work called NanoGrav, the North American Nanohertz Observatory for Gravitational Waves. Their entire method leans on this correction. Before they can compare one pulsar against another, before they can go looking for the faint thing they are hunting, they first move every clock onto the barycenter. It is ordinary. It is done as a matter of course. The correction also lets many telescopes speak with one voice. Addition one place and addition another sit in different spots on a spinning, orbiting planet. Left uncorrected, they would each report the ticks a little differently. Move both onto the barycenter, and the differences vanish. Now every observatory is telling the same time, measured from the same still point that no one can touch. And the reason they take all this trouble is genuinely astonishing. They are listening for gravitational waves. These are ripples in space-time itself, so slight that they reveal themselves only as tiny, shared shifts in the timing of pulsars scattered all across the sky. A passing wave should nudge every clock by a whisper, in a pattern the astronomers have learned to recognize. But that whisper lies buried under the roar of your own movement, so the movement has to go first, all of it, before anything else can be heard. The same trick appears wherever precision truly matters. When engineers fly a spacecraft across the solar system, they do not steer by the Sun either. They plot the path against the barycenter for exactly the same reason. The Sun is not a stable enough reference to trust with a journey of hundreds of millions of miles. Strange as it sounds, the empty point is steadier than the fire, So picture the whole chain once more slowly. A dead star ticking in the dark, a moving planet that smears those ticks, a moving sun beneath the planet, a moving balance point beneath the sun, and a patient team of people lifting away each layer of motion in careful order only so they can hear the star plainly. Even the frame they build at the very end is not truly fixed. The barycenter drifts, and they track the drift as it goes. They are not standing on solid ground. They are computing, moment by moment, the least wrong place to stand. None of it is ever perfectly done. There is always a little more motion to chase, a little more precision to win. The models improve year by year. The subtractions grow finer. The still point they compute is never quite still, only stiller than the one they had before. That is the quiet secret underneath all of it. To catch a tremor in the fabric of space, you must first invent a stillness that does not exist. You compute a point that is not the Earth and not the Sun, and not anchored to anything you could ever reach. You get close to it. You correct for what you missed. You get closer still. There is no chair to sit in, no floor to stand on, only better and worse approximations of a centre that was never there. There is no chair to sit in, no floor to stand on, only better and worse approximations of a centre that was never there. And yet here you are, resting. Notice that. The ground has not betrayed you. It has only turned out to be moving. Let me gather it all one last time gently before you let it go. Think of the layers you have followed tonight. The rock deep in the mantle, tracing its slow monthly circle. Above it, the whole Earth, leaning around the moon. Around both, the sun, tugged into a lazy loop by Jupiter alone. Around the sun, the galaxy, one long lap every 230 million years. And around the galaxy, the fall of the local group drawn toward the great attractor at more than 1,000,000 miles an hour. Each thing circles something, and every something it circles is already in motion. There is no innermost point that finally holds still. Picture the whole cosmos nested like shells inside shells, with no innermost one that finally holds still. Peel one away, and you find another moving inside it. Peel that one, and there is another still. All the way down, and all the way out, the same quiet answer. Nothing here is standing still. Now come back once more to the point beneath your feet. Somewhere around 1,000 miles down, buried in dark, pressurized rock, there is a spot you will never dig to and never touch. It has no marker, it has no surface, it has no light, and around it, once a month, the entire planet you are lying on slowly swings. You have been orbiting it your whole life. You orbited it as a child. You orbited it in every ordinary hour you have long since forgotten, and you are orbiting it right now, without effort, without noticing, without needing to do a single thing. That is the part worth keeping as you drift, because it would be easy to hear all of this as a kind of loss. No fixed centre, no solid ground, no still place in the whole universe to plant your feet and say, "Here, this does not move." It can sound like falling, it can sound like being cut loose, but look at it once more, softly. You are not falling out of anything, you are falling within something. The rock carries you around the buried point. The Earth carries the rock around the moon. The sun carries the Earth. The galaxy carries the sun. The great attractor draws the galaxy on. At every scale, you are held inside a larger, slower fall. That is not exile. That is belonging, widened out past anything you could have pictured. You do not have to hold the center up. There is no center to hold. You do not have to keep the Earth on its path or the sun on its lap or steady the long drift of the galaxies. It was all in motion before you arrived. It will be in motion long after, and you are simply carried inside it. Feel how little is asked of you here. The ground moves without your help, the moon pulls without your permission, the sun sweeps its 250,000,000-year arc whether or not you are awake to watch. You can set the whole thing down. Let it be a comfort then, that nothing waits on you tonight. The point in the mantle keeps its patient monthly circle. The planets keep tracing their long, imperfect loops. The galaxy keeps falling toward that hidden basin no telescope has ever clearly seen. None of it needs you to steer. There is a softness in that. To be small inside something so large that your stillness and your motion make no difference to its course. You are not the pillar holding it together. You are a passenger carried kindly in the dark, and the motion itself is gentle. You cannot feel the earth swinging around the buried point. You cannot feel the sun leaning around its empty spot of space. You cannot feel 500,000 miles an hour, or 1,000,000 more beyond that. It is the quiet motion carrying you like a tide you were born already floating on. You have never once been outside it. You never will be. It asks nothing of you but to rest, so let the diagram go. The tidy picture of planets circling a still sun was only ever a drawing, a convenience, a first sketch of something far stranger and far kinder. What is really here is a long, layered, unhurried fall, and you are one small, warm part of it, carried along without having to try. There is no flaw, there never was, and still you are held. Let that be enough for tonight. You do not need to remember the numbers, you do not need to follow the layers back down. Let the whole nested motion blur into one soft sense of being carried, from the rock beneath you to the farthest pull at the edge of sight. Everything you are resting on is moving, and it has been holding you the whole time. Sleep well tonight. Good night.